Plug-in hybrid technology. A plug-in hybrid has three main elements connected to each other: a heat engine, an electric motor, and a battery that powers the second. The battery is an energy accumulator that is recharged by an external electricity source through a cable and a plug. There are several types for different powers and charging speeds, two variables that depend in turn on the type of charger. It is located in the lower part of the vehicle, normally under the rear seat cushion or under the trunk floor. They are usually lithium and very heavy, about 10 times more than the fuel needed to travel the same distance. Its capacity is generally measured in kilowatts per hour. The electric motor is smaller and lighter than any other combustion engine, as well as much more efficient. It rotates very quickly at double or triple the revolutions per minute than a gasoline or diesel engine, and a gear change is not necessary to regulate the energy that comes out of it and transmit it to the asphalt. However, sometimes they are coupled to the same gearbox, always automated and never manual, as the thermal engine. As they operate with very high voltages, there are a large number of electronic components around this motor that manage its correct operation. Even so, its volume is small. Its power is generally measured in horsepower. The heat engine is a traditional engine that can run on gasoline or diesel. In conventional use, this motor, despite being the main and most powerful motor in a plug-in hybrid car, is only activated when the battery's energy runs out and cannot power the electric motor, or when the driver requires more performance and presses, plus the accelerator pedal, so that both propellers work together. Driving. As the way of driving a plug-in hybrid car is practically the same as driving a 100% thermal car, as the driver demands speed with the accelerator, the electric motor increases its revolutions to move the wheels faster, so it requires more power, which comes from the battery. This is unloaded more or less quickly based on this fact, the orography, wind resistance, the weight of people and luggage on board, among other factors. However, this electricity can potentially be regenerated or recovered during decelerations, as occurs in non-plug-in hybrid vehicles. Subscribe to the Fleet Management channel. Your subscription is a great support to continue making new videos. Subscribe, subscribe, subscribe. When the battery runs out, the combustion engine starts and allows use like that of a traditional car. It is also activated when, despite having sufficient electrical energy, the driver requires the joint performance of the two motors, for example, during overtaking, sporty driving, climbing a mountain pass with a steep positive slope, or entering a highway. It should be taken into account that plug-in hybrid cars accelerate faster with the same power-to-weight ratio, as they offer maximum instantaneous torque from 0 revolutions per minute thanks to the support of the electric motor. That is, they are more reactive, and the user must more smoothly and carefully graduate the movements of their right foot. Also for the brake pedal, since the first part of its travel usually uses mechanical components for energy regeneration, and only with more intensity or pressure is it possible to compress the calipers against the disc. The manufacturer can offer all-wheel drive in this class of cars if it installs a motor on each axle, with the electric motor usually at the rear and the thermal one at the front. There are also models with 3 motors, a thermal motor and an electric motor at the front with a second electric motor at the rear. In this case, the same battery powers both electric drives. Pros and cons. The acquisition cost of plug-in hybrid cars is, as a general rule, higher than that of fully thermal cars, but lower than that of fully electric cars. This will no longer be the case in the medium term, and in the meantime, its maintenance cost is lower. Furthermore, they hardly emit any sound and do not generate local polluting emissions. They can do so indirectly during their manufacturing in electrical operation mode. If they have more than 40 kilometers of electric range, they have a large number of tax and mobility advantages. For example, they are not subject to registration tax, They are exempt from up to 75% of the circulation tax. They can park on the street for free or move without restrictions in specific episodes of high pollution. Unlike electric cars, recharging the battery of a plug-in hybrid car is as simple in theory as it is in practice, since this process is usually carried out overnight. The time needed to regain autonomy is much longer than that used with a thermal car. An average tank is filled in 1 minute, while charging an average plug-in hybrid battery to 80% can take a few hours.
Learned about our fleet management consulting and training services, reduce costs and optimize fleet management activities. We electrify your fleet of vehicles. We carry out the electrification plan until its implementation, known as
Plug-in hybrid. Plug-in hybrids are a transition technology towards 100% electric vehicles. These vehicles are a priori very advantageous, since you can drive them around the city in 100% electric mode and without spending a drop of gasoline, as long as they are used well, charging them every night to have enough autonomy for trips during the day. But this is something that does not happen. In real life, very few users act like this and use the car with gasoline on almost all occasions, or move with it as if it were a self-charging hybrid. This means that the emissions and consumption approval figures disappear. It is a technology halfway between a combustion car and an electric car that has the advantages and disadvantages of offering the best and the worst of both worlds. However, in the WLTP homologation cycle, with just 50 or 60 kilometers of autonomy, cars with 300 horsepower and weights of more than 1,700 kilograms obtain a consumption of around 1.2 or 1.3 liters per 100 kilometers. Even large SUVs 5 meters long remain at 2 liters, and all this because the homologation cycle is very permissive with them. In Spain, plug-in hybrids with a range greater than 40 kilometers have the same classification as a pure electric car. That is the assignment of the General Traffic Direction 0 label, and they can enter and park in low-emission zones in addition to the reduction in the registration tax. Pressure groups such as Transport and Environment, which have a strong influence on European Union legislation, they have issued several reports against plug-in hybrids. The latter claims that these vehicles have hindered the sale of 600,000 completely electric cars during the past year. The goal of a fleet is to achieve net zero emissions. To achieve this, it must use electric vehicles that are 100% recharged with energy from renewable sources, so plug-in hybrids are a transitional solution. Actual consumption versus approved consumption. According to a study by the European Commission, plug-in hybrids consume much more than declared by the manufacturer. It reveals discrepancies between the declared and actual fuel consumption of more than 600,000 vehicles. Plug-in hybrids are far from being as efficient as they promise. Far from stating that cheating is taking place, the European Union points out the misuse of plug-in hybrids. Furthermore, the data collected by the European Union show once again that the WLTP homologation protocol that allows manufacturers to advertise a certain consumption or autonomy does not correspond to the reality of use of a car. In the case of a plug-in hybrid, this protocol is even blatantly poorly designed. Actual consumption versus approved consumption. When the current WLTP homologation cycle was implemented, its objective was to offer the consumer a basis for comparison on equal terms between cars before purchasing, and that was more realistic than the old NEDC, which was totally disconnected from reality. It is not intended to be a reference for real consumption and emissions. In the European Union, they were aware of this. To complement it, it also devised a series of road tests, the RDE, for real driving emissions, and above all, since January 1st, 2021, all new vehicles registered in Europe, including commercial vehicles, are equipped with an onboard fuel consumption monitoring. That perfectly legal snitch records various driving data, including actual fuel consumption or energy consumption for 100% electric models. All this information is stored throughout the useful life of the vehicle and can be accessed without restrictions. The European Commission also collects it anonymously through manufacturers during inspections of a car that is connected to the dealer's diagnostic machine, for example, but also through national authorities, MOT centers, for example, or it can even be sent directly by the car itself, since thanks to eCall, new cars are connected to the network. It is these real use data that have allowed the European Commission to prepare a first report on the differences between the average fuel consumption approved by the manufacturers and that observed by the monitoring device in real conditions. As expected, some discrepancies have been detected. Diesel models consume, on average, 18.2% more in real life than advertised, and the difference rises to 23.7% in the case of gasoline vehicles. The same happens with CO2 emissions, directly related to fuel consumption. In the end, there is no surprise here, and it largely corresponds to the highest consumption that we usually see in car tests. These differences are explained by the relative leniency of the WLTP homologation standards, which yield the figures announced in the manufacturer's technical sheets. These tests, although longer and closer to real driving conditions, as they are carried out under ideal conditions, at 21 degrees centigrade, air conditioning off, do not take into account all the variables of real use, traffic conditions, road topology, outside temperature, driver's driving style, use of air conditioning, etc. Plug-in hybrids emit up to 3 times more than what they are approved for. The real surprise comes from the discrepancies found in the rechargeable hybrid models. Currently, plug-in hybrids, always starting electrically, repeat the approval cycle as many times as necessary until the battery is depleted and perform a single cycle with the battery depleted. In the end, you will have completed between 80 and 90% of the test kilometers in 100% electric mode. It is therefore normal that it shows consumption of less than 2 liters every 100 kilometers, which no one believes. Of the 617,194 vehicles finally used for this study, the sample included 44.5% gasoline, 35.5% diesel, and 20% plug-in hybrids, the latter divided between 80% gasoline and 20% diesel only from the Mercedes and Volvo brands in the case of diesel plug-in hybrids. And in these plug-in cars, the differences are enormous. Adhering to the WLTP cycle, the average fuel consumption of those 123,740 plug-in hybrids would have been 1.69 liters every 100 kilometers. However, according to the car's snitch, the actual average consumption was 5.94 liters every 100 kilometers. That is 4.25 liters every 100 kilometers more. That is 252% more than what is declared by the manufacturers. Although the diesel plug-in hybrids lie the most, 4.42 liters every 100 kilometers more, 330.5%, the gasoline ones are not much better either, 4.21 liters 100 km more, that is 239.2%. Real consumption of fossil fuel and plug-in hybrid. The same fossil fuel model and its plug-in hybrid counterpart, the latter weighs more due to the hybrid technology. So with both models circulating using only the internal combustion engine, the plug-in hybrid model consumes more due to the higher weight. But because the plug-in hybrid model recharges the batteries with braking, it reduces consumption. The most important thing is that according to the graph comparing the same gasoline model and its plug-in hybrid counterpart in reality, without recharging the battery, the plug-in hybrid consumes only 10% less than its gasoline version. The same happens with the diesel versions. However, for the European Commission, the problem is not the cars, but the misuse that is made of them. That is, they are not recharged enough to drive them as much as possible in 100% electric mode. Too often only the combustion engine is used. Under these conditions, the internal combustion engine has to move a heavier car than usual, due to the additional lithium-ion battery and electric motor. As a result of this report carried out at European level, the European Commission is considering modifying the WLTP approval protocol, something that it has been announcing for a few years. Specifically, it wants to reduce the proportion of distance traveled in electric mode, which is currently used to establish the CO2 emissions of plug-in hybrids. Its intention is to impose a new emissions measurement system for plug-in hybrids that could have a significant impact on manufacturing costs and therefore also on the final sales price. So much so that its emissions could be multiplied by 2 if the so-called utility factor begins to be applied. As a result, a plug-in hybrid that today approves 50 grams of CO2 per kilometer will reach 125 grams of CO2 in 2027, which will mean an increase in the cost of ownership of these vehicles since it implies higher taxes and surcharges and the removal of the zero emissions label. Management of the fleet's plug-in hybrids. Vehicle fleets purchase plug-in hybrids mainly for the following reasons. 1. General Traffic Direction Zero label. Increasingly, cities are establishing low emission zones, and to be able to access vehicles, they must have the Zero or Eco label, which is why fleets are purchasing plug-in hybrid vehicles with a range greater than 40 kilometers to access the city center and continue providing the service. This is a bad practice that is not carried out to reduce polluting emissions. 2. Autonomy. The type of electric vehicle available on the market that is needed does not have sufficient autonomy to provide the service, so the plug-in hybrid with the necessary autonomy is purchased. Normally, the objective is to reduce polluting emissions. 3. Price. There are plug-in hybrids that are cheaper than 100% electric ones, and they are purchased as marketing to demonstrate that the company is committed to reducing polluting emissions, and that in reality, this is not the case. This is a bad practice that must be avoided. If you are committed to reducing polluting emissions, you must purchase 100% electric vehicles. The use of plug-in hybrids in fleets. From my experience working with fleets, and according to the European Commission report, plug-in hybrids are not recharged and are mainly used in fossil fuel mode, which only reduces polluting emissions by 10% than its gasoline or diesel counterpart, with a considerable increase in the price of the vehicle, and it is bad practice. Reduction of emissions. To considerably reduce emissions, it is necessary to use electric mode as much as possible in urban environments, because on the highway, the autonomy is considerably reduced due to speed, as well as control and monitoring to recharge the vehicles. Acquisition of plug-in hybrids. From my experience working with fleets, they acquire plug-in hybrid vehicles as property, and they are used for a long period of time, more than 8 years. At the time of purchasing the plug-in hybrid vehicle, a 100% electric vehicle with the necessary autonomy for the fleet may not exist, but in 2 years it will be available. Increasingly, the electrification of vehicles is expanding to all types of vehicles, and the ranges are greater. As hybrid vehicles are used for a long period of time, they are an obstacle to electrifying the fleet with 100% electric vehicles with the goal of achieving zero emissions. If the total pollutant emissions are quantified using a plug-in hybrid vehicle for 8 years, and wait 2 years and purchase the 100% electric vehicle, the total pollutant emissions in these 8 years will probably be lower. If the plug-in hybrid vehicle is rented for 4 years, the obstacle to electrifying the fleet with 100% electric vehicles is lower. Plan the electrification of the fleet. Fleet electrification planning must be carried out before purchasing plug-in hybrids, establishing the maximum time that we will use them. It is necessary to know if the plug-in hybrid vehicle will have a 100% electric model in the future, obstacle or solution to electrify the fleet. The electrification of the fleet using plug-in hybrids is only satisfactory if the following conditions are met. Use the vehicle only in electric mode in urban environments and renew the vehicle when the 100% electric model is available. One strategy is to acquire the plug-in hybrids, and when the 100% electric model exists with the required autonomy, sell the plug-in hybrids and acquire the 100% electric model. Another strategy is to wait for the 100% electric model with the required autonomy to be available on the market and not purchase the plug-in hybrid. The plug-in hybrid is a big obstacle when it is purchased and used for a long period of time because 100% electric vehicles are not purchased when they are available. In certain vehicles that are used in urban environments and that occasionally make long trips of more than 600 kilometers, they may be a feasible option.